Okay, now this is gonna be how you guys are gonna be setting up the armature related to the winding, the asymmetric winding on this Imperial motor. First thing I did is mark our so in here the S1, meaning of pair 1, south 1. So comprehending 7 poles, 1, 2, 3, 4, and the fourth will be your bisector right here. 5, 6, 7. Now these and this red is because I'm gonna be injecting positive, like I said, through the connecting shaft, which is this one right here. Now the bottom is the one that comes with the commutator, is the one that comes with the motor already. If you look at the way that these two commutators are set, more or less, it's about right in between the gap of pole 1, 2, between 2 and 3. So that's where it is at. And the reason why it's so when it hits the when the brush start hitting the first part of it, okay, not the center, but the first part, when the brush is right here and it start getting in contact with this, the bisector must be passing the stator bisector. If it is right center with center, it won't work. The motor could go left to right. So what I did is I did a pattern. Let me zoom back. I did a pattern based on the stator positioning, and it's just a pattern in paper, so you guys have an idea. And I use this line right here as the bolt, where the lower bolt goes. Okay, it's got one bolt above, one bolt below, and that's the base of the stator. So at 90 degrees on the left, it'll be your wires coming out of the motor. That's 90 degrees, exactly as the graphic is displayed. Now, if we go down and look at the brush there, the contact, when it start making contact on the red, right there, if I go, this is the bolt side, this is the bolt hole right there, and if I go here like this and match it, okay, it's got to be passing the stator bisector, S1, in the first tip of touching it, of making contact. So, and that is guaranteed, it's gotta be guaranteed, and you have to check on that on every other bisector. This is N2, which will be on the stator right here. This will be passing it. Okay, it's about, I would say like maybe 10 degrees, maybe less, and so on here. I move a little bit. So the same way here, it's supposed to be passing it, and so with the south of 15. Now remember that we have the other matching pair at 180 degrees when south 1, pair 1 is making contact, is on the other side brush at 180 degrees will be pair 15. So pair 15 supposed to match S1, and S15 are supposed to be 180 degrees apart. And so north 15 bisector is also supposed to be exactly at 180. That's your breakdown right there. So that's what I call to break, to slice the quadrant, the 360 degree quadrant, and this is your primary windings. Now, you don't go and wind S1, P1, and then go P15. No, this is your guide as to set up your how the quadrant is going to go and see if everything falls in place. Now the first the tip of S1 bisector, it's supposed to be, okay, this is S1. Yeah. Okay, I got it right. And 15 and 15. Now it's not squaring out for some reason here. Okay, we got the brush here. The brush is right here. So this is the ball guide. The brush is starting to touch down there, and this is supposed to be like this, because the motor is gonna rotate counterclockwise. If we get our clocks right above the connecting shaft, it's gonna go this way. So your P2 or S2 is gonna go jumping one slot, 7 slot going that way, and it'll be attaching it to the next 2 commutator. Remember, this is 2 because it's 56 elements. So S1 is from here to here, S2 will be here, and so on. Now, like I mentioned on the post where I display the graphic, you should make a check at S8 and then at S15. If S8 or P8 is fine, which you'll be matching like I mentioned it there. But anyways, let's get involved first in the primary setup, which is this one right here. The ball guide is your primary, and then your S1, they're touching this brush right here, which is marked negative on the bottom casing. So this is perfect. This brush right here, this wire is marked negative, so that will be your negative input, and this will be your brush, negative. And the one above is going to be your positive brush. Okay? So that one, we don't have a casing, so we can mark it. The cable, very important. We mark the cable positive, we put a red tape around it, and this will be your negative, the black cable down here on this side. So looking front, it's going to be the bottom cable. So that will be the brush that will be kicking your side, and that will be connected parallel to the other input across 180 degrees apart. So this will give you an idea. I hope this helped you out, and let's take again a closer look at the way I wrote it on the armature. It's so okay, so it's S1, and right next here is S2. Now these two will activate half of this, and N1 and S1. So, and your ball guide, it'll be touching it, and it'll be passing, supposed to be passing the bisector of a status 1, and so on here, everywhere, and it's very close. So that means it'll travel all this on energized until it comes to the other one, which will be right here. The S2 bisector will be right next. So that'll be perfect. So when it goes in, it's gonna, when it finish the writing on the first element, it's gonna collapse right here. It's gonna start energizing right here. So this is perfect. So then you got a very high, basically repulsion motor here, but it's going to be acting attraction towards the nets. The bisector south is going to try to align to bisector north. That's how the name of the game in magnetism works. And once they lock, but they will be disconnected by then. I hope this helped you out, and then we'll start winding it and going coil by coil. Okay, I already started winding the P1, and as you can notice, I started, like I said before, I'm starting from the positive side commutator input, and the one to mark. As you can see right here, I started winding. If I get my watch like this, I started winding counterclockwise. Why? I use my right hand as the guide for winding. This here will be my core, okay, whatever it comprehends. And the way I do it is the positive come towards my fingers and goes like this. Then I will project a north this way, and a south will be my back of the hand. So here I wanted a south projected out. So I started positive going this way, and that will give me the positive coming towards my fingers here. So that will be projecting south here. And then I did 20 turns. I tried with a 16 gauge. It doesn't work. It takes too much room. I did 20 turns on this first coil. And I'm going to see, because you have to realize that each slot is going to have the winding from one coil and the second coil to complete the pair. Plus, we're going to have the other pairs that are coming around, like right here, I believe like P23, will be exactly at this side right here, the south, the north of it. So, but that will be an output, and so on in here. The other pole will be here also. So, the other coil. So we might have conflict here, and this is where I gotta see before I go and determine how many turns I'll be using, and I might have to unwind it, because you can see that I don't have that much room. I'm already doing 20. And I still gotta do 20 from this one, and 20 from the other one, and 20 for the other one. So I don't believe it's still gonna be room. But so you have an idea. This is basically what I'm doing. So this one, I am doing it the other way around. I'm going clockwise on this one. Why? Because then I'll be projecting the positive towards here, and it'll be towards the screen right here, north. So this be it so far, and then I'll keep going. Okay, the previous part I said I was going 20 turns on 18, but it wouldn't work. I still took a lot of space here. And again, we gotta realize we gotta start N1 right here. So S1 is wound this way, project the south this way out, and this one it's clockwise, the N1, so that it'll be, the positive will be coming this way, it'll be clockwise according to my hand, and it'll project a north on this side. But anyways, this is 13 turns of 18 gauge on each, and we have to realize that here we have less timing per coil, because we got 28 coils, 56 coils, 28 pairs. Therefore, we can afford to put lesser turns in the overall, because in the overall machine is going to be taking more times off and less times on. So 13 turns, and what I do is I this paint stick, I use it to push the wire, get it tighter there. After I'm done with each coil, I have to push here, so I can get it back, and so on here and here, so I can get room for the next coil. And also in the bottom, I also push it down towards the shaft, and that way I can get more tension on the wire and gain more room above. This thing is heavy, so I am not attaching the wires. I'm just marking it, and I might put a tape like N1, P1, and then go right next to it. But then I'll, scrape the wire and clean it and do the attachment to the commutator. I have built a tool that I can, this kind of commutator, you gotta squeeze it from inside out. So I built this tool, and I'll get some plastic or wood that will hold me right here, and I'll push the wire up, forcing it to go up. I made this tool so it goes exactly on the slot, and you cannot press on top of the wire because this is metal and it's going to scratch the clear coat, the enamel. So we got it hooked here. I gotta label it, and I'm gonna use one of those spaghetti insulations in between here and to the commutator to avoid when I have cross wires here, so they can make any contact. Then I'll strap it around the neck on both ends with another strap that I'll show you. But first we gotta wire it, hook it, and run some tests. So now my next coil will be P2, which will start here and will end up here, like jumping one slot. And so N2 will comprehend here. Now the conflicts, I'm gonna keep them here, but I'm gonna go clean here, but I still gotta make sure that I am leaving room for the next coils. Now, if you realize the space we got plenty of space to run 26 more wires here, so we're okay. Remember, we got, it was P22, the one that is going to be right above south one. The north of P22 is going to be right above it after I go around. And here, it's like P9, the one that is going to come all the way down here. So remember, this goes around. It's 56 coils turning. So we can afford again to do it with 13, even 12 turns. Wanted to go 15, but that's okay. I went 13. Lucky number. Okay, in order for you guys not to get lost, I am doing this. This is the second pair 2. And if you notice, I have started right jumping one slot. I'm going that way. Remember, this is the top of the motor and the connecting shaft, and the motor is going to be rotating this way. So the next pair will be that way. So P1 is right here, P2 is right here. So the joint of P1 is right here. That's where I put my letters on the diagrams, and the P2 is right here. And if you notice, I'm jumping a slot. Now it's very important that you use pieces of wood and press this real hard so you can leave room for the next coming wires. And you press in here, as also you have to press down here. See, it's so there will be I marked my starting point on the two commutators that are going to be P1 in red right there because it's positive. And here I'm going to put tape on it so I can get them loose, but they're fine right there. Won't be on my way while I'm winding. So now P3 will be from here over here, okay, and from here over here. So that's the way it's gonna keep going, and it's gonna keep growing this way until I go all the way to P1 with P28. Then I'm finished. So you understand I'm going that way. So P1, P2, P3, P4, P5, P6, P7, P8. At P8, I'm going to do a verification of the positioning of the coils.